Learning objectives.
At the end of this topic, you will be able to understand how to calculate median for the grouped data, understand graphical representation of cumulative frequency distribution, draw Ogf curve for the given cumulative frequency distribution. Introduction. As you've studied in Class 9, the median is a measure of central tendency which gives the value of the middlemost observation in the data. For finding the median of ungrouped data, first arrange the data values of the observations in ascending order. If n is odd, the median is n plus 1 divided by 2th observation. If n is even, then the median will be average of n by 2th and the n by 2 plus 1th observations. Median for group data. Let's understand this with the help of an example. Find the median of the following data which gives the marks out of 50 obtained by 100. First, we arrange the marks in ascending order and prepare a frequency table as follows. Here n is equal to 100, which is even. The median will be the average of the n by 2th and the n plus 1 by 2th observations, that is the 50th and the 51st observations. To find these observations, we proceed as follows. Now we add another column depicting this information to the frequency table above and name it as cumulative frequency column. From the table above, we see that 50th observation is 28, 51st observation is 29. So median is equal to 28 plus 29 by 2, that's equal to 28.5. Find the median of the following data which gives the marks out of 50 obtained by 100 students in a test. First, we arrange the marks in ascending order and prepare a frequency table as follows. Here n is equal to 100, which is even. The median will be the average of the n by 2th and the n plus 1 by 2th observations, that is the 50th and the 51st observations. To find these observations, we proceed as follows. Now we add another column depicting this information to the frequency table above and name it as cumulative frequency column. A group frequency distribution of marks obtained out of 100 by 53 students in a certain examination is as follows. From the table, we can observe the distribution given above is called the cumulative frequency distribution of the less than type. Here, 10, 20, 30 and so on up to 100 are the upper limits of the respective class intervals. Number of students with scores more than or equal to 0, more than or equal to 10, more than or equal to 20, etc. From the given table, we observe that all 53 students have scored marks more than or equal to 0. Since there are 5 students scoring marks in the interval 0 to 10, this means there are 53 minus 5 equal to 48 students getting more than or equal to 10 marks. Continuing in the same manner, we get the number of students scoring 20 or above as 48 minus 3, that's equal to 45. 30 or above as 45 minus 4 equal to 41, and so on as shown in the table. The table above is called a cumulative frequency distribution of more than type. Here, 0, 10, 20 and so on up to 90 give the lower limits of the respective class intervals. Now to find the median of the grouped data, we can make use of any of these cumulative frequency distributions. Let us combine the previous tables to get a new table given below. In a grouped data, it is now able to find the middle observation by looking at the cumulative frequencies, as the middle observation will be some value in a class interval. It's therefore necessary to find the value inside a class that divides the whole distribution into 2 halves. To find this class, 1. Find the cumulative frequencies of all the classes and n by 2. 2. Locate the class whose cumulative frequency is greater than and nearest to n by 2, that is 26.5. This is called the median class. In the distribution above, n is equal to 53. So n by 2 is equal to 26.5. Now 60 to 70 is the class whose cumulative frequency 29 is greater than and nearest to n by 2, that is 26.5. Therefore, 60 to 70 is the median class. After we calculate the median class by following formula. So about half the students have scored marks less than 66.4 and the other half have scored marks more than 66.4. Let's list some observations from the previous example. Students have scored marks less than 10 is 5. Students scoring less than 20 marks. The total number of students with marks less than 20 is 5 plus 3, that is 8. We say that the cumulative frequency of the class 10 to 20 is 8. Number of students with marks less than 30, less than 40, so on up to less than 100. This can be done by computing the cumulative frequencies shown in the form of a table. Let's work out some example to calculate the median of the grouped data. A survey regarding the heights in centimeters of 51 girls of class 10 of a school was conducted and the following data was obtained. Find the median height. Solution. To calculate the median height, we need to find the class intervals and their corresponding frequencies. The given distribution being of the less than type. 140, 145, 150, and so on up to 165 give the upper limits of the corresponding class intervals. So, the classes should be below 140, 140 to 145, 145 to 150, and so on up to 160 to 165. Observe that from the given distribution, we find there are 4 girls with height less than 140. That is, the frequency of class interval below 140 is 4. Now there are 11 girls with heights less than 145 and 4 girls with a height less than 140. Therefore, the number of girls with height in the interval 140 to 145 is 11 minus 4, that's equal to 7. Similarly, the frequency of 145 to 150 is 29 minus 11, that's equal to 18. For 150 to 155, it is 40 minus 29, that's equal to 11, and so on. So our frequency distribution table with the given cumulative frequencies becomes So, the median height of the girls is 149.03 centimeters. This means that the height of about 50% of the girls is less than this height and 50% are taller than this height. Let's move to another example. The median of the following data is 525. Find the values of x and y if the total frequency is 100. Now that you have studied about all the three measures of central tendency, let us discuss which measure would be the best suited for a particular requirement. The mean is the most frequently used measure of central tendency because it takes into account all the observations and lies between the extremes, that is, the largest and the smallest observations of the entire data. It also enables us to compare two or more distributions. However, extreme values in the data affect the mean. For example, the mean of classes having frequencies more or less the same is a good representative of the data. But if one class has a frequency, say 2, and 5 others have frequency 20, 25, 20, 21, 18, then the mean will certainly not reflect the way the data behaves. So in such cases, the mean is not a good representative of the data. In problems where individual observations are not important and we wish to find out a typical observation, the median is more appropriate. Example, finding the typical productivity rate of workers, average wage in a country, etc. These are situations where extreme values may be there. So rather than the mean, we take the median as a better measure of central tendency. In situations which require establishing the most frequent value or the most popular item, the mode is the best choice. Example, to find the most popular TV program being watched, the consumer item in greater demand, the color of the vehicle used by most of the people, etc. Graphical representation of cumulative frequency distribution. A graphical representation helps us in understanding the given data at a glance. In Class 9, we have represented the data through bar graphs, histograms, and frequency polygons. Let's now represent a cumulative frequency distribution graphically. For example, let us consider the cumulative frequency distribution given in the table. To represent the data in the table graphically, we mark the upper limits of the class intervals on the horizontal x-axis. Mark the corresponding cumulative frequencies on the vertical axis, y-axis, choosing a convenient scale. The scale may not be the same on both the axes. Plot the points corresponding to the ordered pairs given by upper limit, corresponding cumulative frequency. That is 10, 5, 20, 8, 30, 12, 40, 15, 50, 18, 60, 22, 70, 29, 80, 38, 90, 45, 100, 53 on a graph paper. Join coordinates by a freehand smooth curve. The curve we get is called a cumulative frequency curve or an Ogf of the less than type. Next, again we consider the cumulative frequency distribution given in the table and draw its Ogf of more than one type. To represent the more than type graphically, we plot the lower limits on the x-axis and the corresponding cumulative frequencies on the y-axis. Plot the points, lower limit, corresponding cumulative frequency, that is 0, 53, 10, 48, 20, 45, 30, 41, 40, 38, 50, 35, 60, 31, 70, 24, 80, 15, 90, 8 on a graph paper and join them by a freehand smooth curve. The curve we get is a cumulative frequency curve or an Ogf of the more than type. Relationship between Ogf and median. From example 1, n by 2 is equal to 53 by 2, that's equal to 26.5. On the y-axis. From this point, draw a line parallel to the x-axis cutting the curve at a point. From this point, draw a perpendicular to the x-axis. The point of intersection of this perpendicular with the x-axis determines the median of the data. From the graph, median for the above data is 26.5. Another way of obtaining the median is shown. Step 1. Draw both Ogfs, that is of the less than type and of the more than type, on the same axis. Step 2. The two Ogfs will intersect each other at a point. From this point, if we draw a perpendicular on the x-axis, The point at which it cuts the x-axis gives us the median. Let's consider an example. The annual profits earned by 30 shops of a shopping complex in a locality gives rise to the following distribution. Draw both Ogfs for the data given. Hence obtain the median profit. We first draw the coordinate axis with lower limits of the profit along the horizontal axis and the cumulative frequency along the vertical axis. Then we plot the points 5, 30, 10, 28, 15, 16, 20, 14, 25, 10, 30, 7 and 35, 3. We join these points with a smooth curve to get the more than ogive as shown. Now let us obtain the classes, their frequencies and the cumulative frequency from the table above. Using these values, we plot the points 10, 2, 15, 14, 20, 16, 25, 20, 30, 23, 35, 27, 40, 30 on the same axis as in figure 1 to get the less than ogive as shown in figure 2. The abscissa of the point of intersection is nearly 17.5, which is the median. This can also be verified by using the formula. Hence, the median profit in lakhs is Rs 17.5. Summary. Let's summarize the topic. The cumulative frequency of a class is the frequency obtained by adding the frequencies of all the classes preceding the given class. The median for group data is formed by using the formula, where symbols have the usual meanings, representing a cumulative frequency distribution graphically as a cumulative frequency curve, or an ogive of the less than type and the more than type. The median of group data can be obtained graphically as the x-coordinate of the point of intersection of the two ogives for this data.